first thing we'll do is we will convert this into an augmented matrix. So this will become 1, 2, negative 1, 1, and then negative 1, negative 2, 2, negative 2, 3, 6, negative 3, 3. And again, for the augmented matrix, you want to make sure your x's, your y's, your z's, and your numbers are lined up, and they are, so everything's good. All right, so we'll start with row 1, get our leading 1, and then the zeros below it. So to get the 0 in row 2, because we already have the leading 1, we'll have to take row 2 and then add that to row 1, because the 1 plus the negative 1 would cancel to the 0. So my row 2 is looking like negative 1, negative 2, 2, negative 2, and I'll be adding that to row 1, 1, 2, negative 1, 1. Okay, so this gives us 0, 0, 1, negative 1, and that is our new row 2. Now, while we are at it, let us look at row 3, which also needs a 0. So we'll take row 3 and then minus 3 times row 1. And then that will give us a 3 minus 3, which will cross to 0. So we take our row 3, which is 3, 6, negative 3, 3, and then we multiply row 1 by negative 3. So that gives us negative 3, negative 6, positive 3, negative 3. And we add those two together to get 0, 0, 0, 0 as our new row 3. Now, we could put this together as a new matrix. However, anytime you have a row of zeros, that means that you're going to have infinitely many solutions. And there's many ways that you can write the infinitely many solutions. Usually what we like to do is we like to write it as an x, comma, y, comma, z order pair. And so if you put the matrix together, you'll kind of start to see that. So using what we did up above here, we have our first row as 1, 2, negative 1, 1. And then in row 2, we have 0, 0, 1, negative 1. And then in row 3, we have 0, 0, 0, 0. And we know that that results in infinitely many solutions. Now, what you could do to see exactly how to write this is you could write this as getting a leading 1 here and then a 0 above it. So just very quickly here for row 2. So with this, you would want to get row 1 as a 0. So you would take row 1 and add that to row 2. So you'd have 1, 2, negative 1, 1, and then 0, 0, 1, negative 1. And if you add those two together, you get 1, 2, 0, 0. So this is your new row 1. Okay, so how does that help us in writing our infinitely many solutions? What would happen is you would have 1, 2, 0, 0, 0, 0, 1, negative 1, 0, 0, 0, 0. So what this tells you, this matrix right here, is it tells you that x plus 2y is equal to 0. So x plus 2y equals 0. And it tells you that z is equal to negative 1. So what we can do with that information is we can solve this equation for y. So we'll write this as, if we solve it for y, we'll have 2y is equal to negative x, and then divide both sides by 2 to get y is equal to negative x over 2. So we write x, comma, y, comma, z, but then based on our solution for y, we could write this as x, comma, negative x over 2, comma, negative 1. And then that would be our representation of the infinitely many solutions.